So let's go ahead and get started. It's about 2 after the hour, so I think we can go ahead and start. Get rid of this message up here. It's kind of blocking everything. All right, so our learning objectives for today's module, and it looks like there's a lot of them because we have a lot of new discussions today about the extension packages. We've briefly talked about some of the C extension libraries that are provided to Genero and Genero Mobile. So we'll be visiting some more of those. Some of them we haven't talked about yet at all, I don't think. So there's lots of objectives. First thing we're going to talk about here is integrating code from an external module. That's actually using the import statement. So I think I actually deleted that this morning because we've already talked about the import statement and how you can import external modules into your application. So that was there early on, but we've talked about it, so I actually removed that page. I just forgot to remove it from the learning objectives. So really the first topic this morning is describing the benefits of integrating web components into your app. We've talked about these front-end functions at various times during the last 2 weeks. So we've got some additional front-end functions we're going to look at today because there's a special web component module. Remember we talked about all the different front-end calls we have for devices, like we had the standard, the mobile extension package module that we talked about. There was one specifically for iOS and another one for Android. So we've talked about a lot of these front-end functions that we have, or front-end modules. Well, here's another one called the web component module that we'll talk about in this chapter. So in the process of discussing web components, one type of web component, the first one we talk about, requires an interface script. So we'll learn about this interface script that you use with what they call gICAPI web components and what that interface script does. We'll talk about how to define a web component field in a form file. That's how you implement or embed web components in a Genero application, is by creating a special form field in a form that has a special component type. Then we'll talk about using the web component in the dialog of a program. So once you have your web component all configured, you just work with that web component or interact with that web component just like you would anything else right there in the dialog of a program. And then the last part of the chapter today is talking about data synchronization. So we'll describe techniques to do data synchronization, and our example uses RESTful Web Services with JSON over HTTP. So we'll look at some of the there's actually a special set of JSON classes that you can use to work with serialized data. For example, this synchronization routine gets data in a serialized format from a back-end server, and then we use some special JSON class methods to go through and parse that data and convert it to a format that we can use to insert into our database tables locally. The Android API I actually removed because it looked to me like we had about all we could talk about for today. So if we have time tomorrow, I'll go ahead and slide that in tomorrow. So our first big topic today, and it's probably 3/4 of our material, is on web components. So a couple of ways you can think of web components. Here it's saying web components are specs that web developers use to build widget templates that can be reused easily and reliably. So I think most people just think of web components as the widget templates. So any way you want to think of them there is fine. The idea is a standardized type of template that once you get familiar with the syntax and the format and the way they're implemented, it makes it easier for you to work with other third-party web components. So it is a set of specs, right? It's a standardized set of specs. You can use these third-party components, these web components, to add value to your BDL apps. We certainly have options for charting and graphing and that type of thing, but there's some third-party tools out there that do a lot with charts and graphs. You can embed calendar widgets with web components, drawing widgets, all kinds of really neat third-party graphical components to kind of jazz up your applications if you want to. You have to be careful about the ones you use because some of them are free, some of them are licensed, so before you get too carried away spending a lot of time implementing these web components into your apps, make sure there's not some licensing issues that may end up costing more money than you were expecting. So be aware, some of them are free, some of them are not free. Web component types. I mentioned earlier that there's special interface scripts that are used with one type of web component, and that's this first one, the gICAPI web components we have at the top. So gICAPI web components require a set of files to be able to use them. There's typically this interface script that I mentioned earlier that's part of the gICAPI web component. It's the part that we actually use to interact or communicate with the web component through a BDL program, a 4GL source file. So it requires an interface script. All the web components require a form file, so that's an additional file that's required. And in the case of gICAPI web components, sometimes there'll be some external files additionally, CSS files, maybe additional JavaScript files and that type of thing. So one of the first things you have to do is make sure you have all the required files to be able to implement a gICAPI web component. And then those files have to be packaged, so when you deploy the app, these gICAPI web components are part of your deployment. They have to be on the front end. The URL-based web components are easier to work with. They don't have all these required files. You don't have to worry about making sure you package any of those required files. So less to work with and easier to program. So URL-based web components are actually hosted on a third-party server. An example of that is Google Maps. We've got an example of using Google Maps in our module here when we get to the URL-based web component topic in the module. I mentioned earlier that we have a special module with these front-end functions that we've talked about a few times already in the class that allow you to interact with the front end, or it's actually performed by the front end. So here's this UI interface.frontCall classes that we've been talking about, and it has some special methods here just for web components. So there's a special module that's provided called the Web Component Module. The main call, or the main method in here, is this call method, and that's the one that you'll see in at least one of our examples in this module that allows you to call a JavaScript function through a web component. So we'll see that, I believe, right here in the gICAPI section of our web component topic. There's a couple of other methods, this front call API version and get title method, but you can see both of those are not as significant. The front call API version just returns the API version of the web component. You'd probably be using that for troubleshooting purposes, I imagine, just to make sure if you were having a problem you had maybe the latest and greatest. The get title returns the title of an HTML doc that might be being rendered by a web component. So you might use those on occasion, but probably the most important method is that first one, the call method. And we'll see that one in one of our examples. So our first web component type or topic that we're going to look at here are these gICAPI web components. We mentioned already that there's usually several files required to be able to implement a gICAPI web component. It's the older type of web component. If you can call web components old, this would be the old type. But it does require an interface script. You can see that Here's our interface script. It's HTML. Grab my highlighter here so I can point these out. We use a gICAPI web component to invoke the splash screen here for our Pool Doctors app. So that'll be your first look at a gICAPI web component. You'll actually implement this splash web component, we call it, in your lab this afternoon. So these are the files that you'll need to be able to implement your splash screen. The interface script is the first one, this programmable.html. It requires a form file with the special web component type form field. It's a special widget that you create for your form, and that allows us to embed the web component or attach the web component to the form file. And then you have a BDL program that's going to interact with the web component through this interface script, in this case programmable.html. It's got some JavaScript functions in it that we'll look at. And then finally, our splash screen you can see is an image, and the name of the image in this case is Splash iPhone 5. So that's what we're actually seeing in that screenshot. That's what the Splash iPhone 5 image looks like. And we're just using that image to take up the entire screen to create a splash screen. So there's our files that we need to use for our gICAPI web component for the splash gICAPI web component. We're going to have to implement the gICAPI interface script. It's pretty much implemented for you, this programmable.html. And then define the location for the files so that they can be found, right? We want our application to be able to find those files when we're ready to run the app. The form file, remember, has to have some special web component types, or it's actually a special property, component type property set, and it has to have this special widget, this web component widget. And then you just use the web component in the dialog of your program. So we'll just have a regular 4GL source file out there that's interacting with the web component via this interface script. So more about this interface script. The web component API relies on a gICAPI object. So you'll find the gICAPI definition there in the interface script. We'll take a look at it here in just a minute. So the purpose of this gICAPI global object is to be able to communicate back and forth between the web component and the BDL program. So the web component has to be able to transfer information or request over to the BDL program, and vice versa. The BDL program needs to be able to communicate or interact with the web component and be able to initiate that conversation. So that's the purpose of this gICAPI object that you find in the interface script. So this is what the programmable.html interface script looks like that we're using for the Splash web component. So this is just, you can tell, just a small excerpt from it, although it's not very large. There's not a whole lot in there. But this is an excerpt from it, and you can see here are the special methods for this gICAPI object that are used to communicate from the web component to the BDL program. There's this gICAPI set focus that's used to send a focus request. There's a set data to be able to pass data that's been set in the web component back to the BDL program. And finally, this gICAPI.action method is able to raise an action. In our case, it's raising an action that gets passed to it called Splash. So that's how we know that we're supposed to trigger an action that does something. So in our BDL program, we're sitting there waiting. Once we invoke this web component, we're in an input by name, just sitting there waiting for some input by name or some input. And then whenever a user taps on our splash screen, there's this special onClick method that's attached. And in that onClick method kind of triggers an action that calls this function, exec action, here in our interface script and then raises this action, and it passes the splash action in. We'll see that in more detail as we go through here. So once that action is triggered, of course this web component, notice this is from the web component to the BDL program. This action is triggered and that information goes back or is communicated to our BDL program so that it sees that the splash action has been triggered. So that's what actually triggers the action splash. Somebody tapping on the splash screen, tapping on the web component, which triggers this special on-click method and raises an action. Now going the other way from the BDL program to the web component, we've got these gICAPI methods to communicate with the web component, but if you remember we also have that front call, the front call method that we can use to interact directly with the web component and call the function that way. So we can use that front call method, and we also have these special gICAPI methods that we can use to communicate with the web component. So there's an on-focus method that's called when the program, the BDL program, sets the focus in or out on the web component, gives it focus. There's an on-data method that's used when a form field value changes. So if the web component needs to react or do anything based on a form field value change, that's how that information is passed to the web component. Maybe it's supposed to display something different or show something else. On property is called anytime a property is changed or added or removed. That's a method to be able to communicate that to the web component. Now in our programmable interface script, the one for our splash screen, we don't really use any properties at all. There are no properties for our splash screen. About the only thing we're really concerned about is getting the focus. So this gICAPI dot on focus is used, and of course that polarity is true or false basically. So if it's in focus, then that polarity is true. When you're working with web components in general, and especially these gICAPI web components, to be able to find the files, or for the application to be able to find the files, you need to make sure that you store them in a standard directory. You can't just have these web component, like the interface script in one place and maybe the form file in a different place and so on. So there's standard directories for you to put those things, and happily with our BAM mobile projects, if you remember, it actually provides a web component directory. So make sure that you store all of these special files that you use with these gICAPI web components in your web components directory structure. Now an exception, of course, would be, for example, with our splash screen, we're using an image. So that iPhone 5 image that we looked at a few minutes ago, you can put that in your images directory because we do have environment variables, of course, that can find it there. But for the most part, your web component file, these HTML files, any special JavaScript files that you need for a web component, you're going to store them in your directory structure in the web components directory. And that way, when we get to the packaging, everything gets packaged correctly for deployment. So if you'll go ahead and store everything in these standardized directories that are provided for you, it saves you a lot of trouble or time at the deployment stage. So there's the standard directories. I just recommend that web components directory there that's provided for you. But this is just saying you can store them as long as it's in your, they're calling it the application directory here, but think of it as your project directory, and you can just store it at that level. I would recommend the web components level, like we see here in this screenshot. But you can also, if you have a lot of web components you're using, you can put them in subdirectories. This last example down here at the bottom is saying if you have a lot of them, you can actually create a subdirectory under the web components directory for each web component. And you can just put The directory name there would be your web component type, and then you can put all of your component files, your interface files, and so on underneath that special directory for that web component, and that's supported as well. So right now, we're using this method at the bottom. The application for us, we're in development mode, is executing on a server, and we're just displaying it on a mobile device. So like we're doing, we're in development mode. We can just put our gICAPI files, we've got them on our server, and then we just want to make sure that we have this FGL image path environment variable set so that it can find all those special files for the gICAPI web components. There's a special step that you need to do if you want to be able to work with your gICAPI web components in Form Designer. Now, what some folks have done, or a lot of people have done working with web components to date, is a lot of people use the .per format, the text-based format for form files. You don't need to do that if you like Form Designer and prefer to work in I guess a more intuitive interface. What you can do is make these web components available to Form Designer by creating a special configuration file. It's not that complicated. You give it a special name. It's whatever the name of the web component is, .wc settings, web component settings, WC settings. You can see here from this picture, this screenshot, that it's an XML file, and all it is a set of all the properties that the web component you're working with has. So that's all you're doing here, is describing the properties. And that allows the Form Designer then to have those properties available when you're working with that web component in Form Designer. So that's the purpose of this WC settings file. And again, if you're not going to be working in Form Designer, this file is not required. It's just if you want to use Form Designer, you need this file so that Form Designer has access to these properties, or can give you access to the properties. And just like we saw before, saving all these WC setting files, make sure you store them in a standard location. And again, that web components directory is just fine for those. Okay. One other thing I probably ought to mention about these occurred to me just as I was changing the page. Now, these WC settings files are not required to run the app once you have your web component, you're past the development mode and you have your web component all integrated with your app. That WC settings file is just for development while you're working with the form file. And once you're ready to package, that WC settings file is not required. Once your form is compiled, everything's linked, it's no longer needed once that file is compiled, the form file. All right, just to make that clear. Now, the WC settings files, again, I would store them in a standard location to make sure it's easier for you. You could store them somewhere else, because one of the things you'll be setting so that the Form Designer can find them is a special environment variable, GST-WC-dir environment variable. Again, it's only needed for development so that our Form Designer can find these special configuration files, these WC setting files. So you could put them somewhere else, but notice here I've put these in the standard Pool Doctors Web Components directory. Just makes development easier because you don't have things scattered out. Everything's in one place, so you don't have to worry for troubleshooting purposes. I don't have to look 4 different places to find everything. So notice it's a special environment set. This Web Components environment set has the GST-WC-dir environment variable in it, and you just want to specify the directory where you've stored your WC setting files for Form Designer. So now we're ready to define the form, or at least talk about defining the form here. So notice here we've got to have a form field, and it's a special form field just for web components. So here you can see we've got our form just like we always have in Form Designer. Not much different looking about the form, but notice that we do have this form field. It's a form-only form field, and it's a special web component widget type. And then down here towards the bottom, this is mandatory for a gICAPI web component. It is not mandatory for the other type of web component, the URL-based web components that we're going to talk about next. But for the gICAPI web components, the purpose of this component type property is to point to the interface file that's one of the requirements for a gICAPI web component. So this maps to your interface file. So for this component type, you specify the interface file there. So ours, remember, was programmable .html, so our component type is programmable. And it's finding these component types to pick from in this combo box, this drop-down box, by looking at that GST-WCDIR environment variable that we just talked about on the previous page. So it's going out there to look for those WC settings files that we just talked about, and this is a list of the ones that it found when this screenshot was taken. So that's how it gets the drop-down, the combo box values, is from the directory specified in that GST-WCDIR environment variable. And if you don't have that set, you won't be able to pick anything from the combo box. So here we're interacting with the web component. So it looks fairly complicated, and it does require going back and forth some, but once you've gone through it a bit, it's really not that complicated. It just looks like it when you first see it. So this is that front call method that we talked about 3 or 4 pages ago. So here we're actually using a front call method, that's the name of the method, in our splash.4gl program to start off the process with our splash screen. All right, so that's how we're initiating the whole process. So we're making this UI.interface.frontCall web component here, just to remind you of how these front calls work. Web component is the name of the module that the front call method is in, so it knows where to look. So it's web component. This is the name of the function or the method for the front call. This is the web component. This is actually the name of the web component as it would look in the abstract user interface tree. So if you went into your tools, Android tools, and brought up that AUI tree that we've seen a few times in class this week, you would be able to find your web component, the form name, the form field name of your web component would be form-only splash. You'd be able to see it that way. So that's the name of basically the form field for your web component. And in the interface script for that web component, it's calling a function here, setById. When it calls that function, setById, it's passing it one literal value, root, and then it's also passing it the results of the splash HTML function. So that's the part to me that seems a little complicated. So it's calling a function in the interface script, passing it some parameters, but one of the parameters it's passing is actually the results of a function. So that splash HTML function, I've squeezed it in here so you can see what it looks like. You can see these are just excerpts from these files. But further down in splash.4gl is the splash HTML function that it's talking about up here in this front call method. So right here, this is all this function does, is it's passing back some HTML back for this function to be invoked with, or to pass to this function setById when it's invoked. And you can see that essentially it's our Splash iPhone 5 image and all the settings for that. So basically it's going to take up the entire height and width of our web component form field. So height equal 100%, width equal 100. And notice at the same time, it's attaching this special on-click method with this object that it's creating, and it's going to on-click, meaning that when a user clicks in the web component field, in the form field or in the web component, it's going to trigger an action, basically trigger an action that runs this exec action function, or exec action function, and pass it a literal splash. So splash happens to be the name of our action in this case that we're passing back. So that's kind of a lot to look at there on one page. But just to summarize, we're using a front call. In that front call, we're going to call a function that's in the interface script called setById, and we're passing it some parameters, and essentially we're passing it the contents of our web component, what we want to be displayed on the screen. And along with that, we're kind of embedding or attaching this special on-click method so that the user clicks or taps on the splash screen, it's going to call another function, exec action, in our HTML script and pass it the value splash. Down here at the bottom is the setById function, again just a small excerpt from the interface script, programmable.html. And the setById, you can see here, not a whole lot to it either. It just says, okay, I've got this, I'm a function, I'm accepting a couple of parameters. One of them is an ID, the first parameter. And notice the ID we're passing in up here is root to this setById function. And I'm also being passed in a value. And the value is all this stuff down here at the bottom. Let me get rid of all my drawings here so you can actually see what I'm pointing to. The value is right here. This is the value that's getting passed in, all of that. So that's what's getting passed to this function when it's getting called. And then what it's doing here is just replacing, it's doing get element by ID, and the ID is root, which is right down here. And it's just basically an empty division here. And then we're replacing the HTML for that root div with all of this return value here at the top. So replacing that with all this, this Splash iPhone JPEG and the settings for it, which will take up the full height and width of that div. So that's how we're displaying a value to our web component, or displaying an image to our web component. And in the meantime, here we sit in our 4GL program, our VDL program, splash.4gl. We've got our input by name, splash, and we're waiting basically for some input from the user, and the input in this case would just be a tap. So when the user taps, if you remember, that's going to invoke this on-click method that's been attached to the object that's being passed in. Can't tell if you can see this guy. And when the user taps, that's going to cause it to run this function, exec action, and then pass it this splash literal. That is going to in turn raise the action splash. That gets passed back to our BDL program. So our input by name says, okay, on action splash, now that the user has tapped in the web component, I'm just going to exit input. And then our BDL program goes, at that point we're back in the main, and it should go ahead and display our first form for the application. What was that? Job header list, I believe. All right, so let's take a look at it. See if I can grab the right thing here. There we go. got some of these files we've been talking about already pulled up here on the screen to make it quicker for us. So I guess the first thing is, we talked about these environment variables and whatnot to get everything set up properly. Let's take a look at that quickly. I'm just going to do this display environment here. And point out a few of these. Here is, I'm just going to click on it. Well, I need to highlight it, I guess. Can't see it after all. GST-WCDIR environment variable. Remember, that's pointing to the location of those special WC settings files for these special gICAPI web components. I've got that set, and I'll show you where here in just a moment. Let's see. Another one here. FGL image path. Notice I've got my Pool Doctors web components in my FGL image path as well to be able to pick up these web component files. Remember, when you're working in development mode, you can just use this FGL image path environment variable. I think we'll revisit that here in a few minutes in the second section as well. So just remember, I've got that set to not only my images directory, but also my web components directory as well for development reasons. Now over here in my configuration file, just in case you can't see it down there in the corner, I'm going to use this method, Tools, Genero Configurations. So here's my Android x86 configuration, and I have my web components environment set selected here, and then over here is my GST-WCDIR environment variable, and you can see that I have that set here. So that's why that environment variable was set that we just looked at. So just a few environment things there to look at. Cancel out of that. And just to kind of get a look at the splash screen, let's go ahead and execute it so you can see. Of course, I'm going to have to tap on it to make it where you can see it. There we go. I brought it back. So there's the splash screen that we're talking about here. And all I have to do is tap. And when I do that, that is that on-click method that was attached to the object that was passed in. That then raised an action, the splash action, and caused us to exit our input. And it goes now into the generated part of the app where it's opening the first form. Okay, so let's take a look at some of these files then. So here's my form file. This is splash.4fd. And if I pull that down a little bit, you can see it. Here is it's just a regular form up until this point, and then I've got this splash web component. Raise this up so you can see it. The name is Splash, and the reason it looks different from what you've seen before with the special icon is just because it's been converted to a web component widget. Now one thing, I haven't really talked about this anywhere, but let me just point it out since it's right in front of me. This stretch property, typically when you're working with web components, a lot of times they're graphical objects, things like charts and graphs and images, that type of thing. So most of the time you want to set this stretch property for them, and typically you would set it to both. There are different settings, but a lot of times this will be something that you will change in your properties, will be this stretch property to make sure that it is resizable. A lot of them are resizable, and that allows them to be resizable. Let's see, where was I really going? Okay, here's this web component section. So this component type is important for gICAPI web components. So here's our programmable component type for our splash screen. Well, rats, I don't have my environment variable set right, but it's already embedded in here. But if I had my environment variable set correctly where I have my WC settings files, then I would see them all here in this drop-down list. That was my mistake. Beg your pardon. So there's our form file. This whole area here is the area, the display area for the web component. So let's take a look at some of these other files. Let's take a look at main here. Notice up here at the top, this is our generated main.4gl that we've been looking at for the last couple of weeks here. But notice we've added some custom code here to this import point that we talked about. Can't remember if it was yesterday or the day before. So we had to import the splash.4gl module. And this is how you do that. Import FGL splash. So that's been imported so that we can call functions from that external module. Scroll down here till we and then right down here in this function main open first form, we're getting ready here to open that first generated form. But before we do, right, here's the call to open it. Call job header list UI open form. Before we do, we have another point. FCT open first form init. And that's a good place for us to sneak in this call to our 4GL program, our splash.4gl, to invoke our splash screen. And the way we do that is calling splash.execute. So that's what we have in our main.4gl that's going to use this web component to display a splash screen before we open our first form. So now let's pop on over to this splash.4gl. Take a look at it here. So this is our imported module. Here's the function. Actually, I've forgotten. Splash.execute. Okay, that's the function we're looking for, is the execute function. So let's go find that. Must have missed it. No, it's way at the top. Okay, sorry, I missed it. I blew right by it. So here's this execute function. All it does is open Windows Splash with form splash. So that's our splash.4fd that we were just looking at. So it opens a window with the form, calls another function called splash. And then once that function executes, it's going to close the Windows Splash because at that point we're through displaying our image. All right, we're ready to go ahead and call that first form and go back to the main. So here we're looking for the splash function. Happily it's right below, so I don't have to go off looking for it. Scott's pointing out something very useful. If I had just gone over here, I could have easily found my execute function that way. All right, thanks Scott. So here it is, private function splash. Let's look for something. Here we go. This is what we're looking for. UI.interface.frontCall. So here's that special front call method we talked about that's calling the web component module. In that web component module, we're going to call this call method. It's going to work on the form-only splash web component. So this is the name of the web component, form item. And in the interface script for that web component, it's going to call the setById function. So that's what we're calling, is this setById function in this web component, passing it root as a literal value, and then the result of this splash HTML function. Well, I guess I'll pop over there and find it the quick way. So here's private function splash underscore HTML. Just like we saw in the PowerPoint presentation, there's really nothing in here except returning this piece of HTML for the web component then to display. So all of this is just some HTML that's going to be used to replace what's already there. There's our Splash iPhone 5 JPEG that's going to be used, all these special settings to take up the full screen, and then here's this on-click method that's built in to this HTML, this object that's being returned back, with this exec action splash. So here it's going to say, it's saying anytime then that a user taps within the web component, that's our on-click method that's kind of built in, that's going to call this exec action function and pass it the value splash. Alright, so let's just take a look at that. So here's this function that we keep talking about. Here it is in our interface script. So exec action equal function. So it's passing in splash. So when splash gets passed in, it's going to use this gICAPI action or trigger or raise an action, and the action to be raised is the value that's being passed in, and the value passed in was splash. So that's kind of a lot to kind of keep track of, but that's what's going on. And then over here in splash.4gl, we're sitting here in this input by name. And then right here, when this on action splash, when the action splash is raised, we've added some to it since we actually created the screenshots, but here it's opening the first form, right? Calling this job header list UI open form, and that gets us started with our generated application. So it's a little bit of a chore the first time, I guess, to track through all the steps in the web component, but once you've looked at it a few times and followed through on the logic and kind of bounced back and forth between these files, it gets easier to follow, and shortly you'll start thinking of all the things that you could do with it yourself. That seems to be the way that works. So take a little time this afternoon when you're working on the lab to explore these files and figure out exactly how they're communicating with each other and back and forth, and you might be surprised with the things you think of that you can use this with. All right. Any questions about that gICAPI web component before we go on to the next type? We're going to look at a different type of web component that's actually easier to implement than a gICAPI web component. They're the more complex type. Well, the second half of our web component topic is on URL-based web components. You'll find that they're a lot easier to program. They don't require any of these special interface files to come along with them. All you need is a URL for URL-based web components. Alright, so using a URL-based web component. So to use a URL-based web component, as we mentioned, you don't have to have the interface files or anything of that nature. You don't need a WC settings configuration file for Form Designer for URL-based web components. So they are easier to work with and easier to program as well. There's not much programming. But we do still have some steps. We do still have some form file work to do to use a URL-based web component. So we'll go through the steps here and take a look at one. So the first step is identifying the URL of the hosted web component you want to use. So instead of having all the files here and having to keep those files on our front end like we do a gICAPI web component, instead all we need to do is have the URL, and we have all the files that are needed on this web server out there, right? A hosted web component. So that's easier for us to use, and we're not even responsible for keeping track of all those files anymore. 2 or 3 pages of the last topic were on making sure we have everything in the right place so that our application can find it. We don't have to worry about that with URL-based web components. We do need to define a web component field in the form file, very similar to the way we did for gICAPI web components. In the program, set the URL of the web component in the form field value. In the program, detect user interactions with an onChange control block and control the web component with front calls. Now that's optional, right? I don't have to use the onChange control block. We're just saying that so if you do decide you need to interact with the web component based on user changes and that type of thing, you can detect user interaction with an onChange control block, an optional thing. Same thing for front calls, right? Those are tools that you can use if you want to use them or if you need them, but they're not mandatory. So here is a URL-based web component that I'll show you here in a bit after we take a look at all the steps for implementing a URL-based web component. But this is one that's utilizing Google Maps, essentially. So our URL involves the Google Maps URL. So there's just two files involved. Notice we don't have to have any kind of an image file for this URL-based web component. There's no interface file, no WC settings file. So all we have here are the form file and the VDL program, the source file. Much simpler. So here's defining a form for a URL-based web component. Since we don't have to have a WC settings file because there's no interface script for a URL-based web component, we just leave that component type property empty. Right, so we don't have to find a WC settings file that maps to an interface file for us. Nothing like that is required. So in this case, we just leave that blank. We leave it at the default, but we still need to go in and set up our web component widget. So this part is still just like the gICAPI web component. So all that part is the same. We have the web component widget. We give it a name, but we don't have to have the web component type. Gerald has a question. Where are you selecting the widget? You'll just add a form field to your form, just like we always have. And if you remember how in your lab you changed an edit field to a phantom widget, you do it the same way, Gerald. Good question. Right, so you do just that convert widget option. You convert it to a web component widget. Let me just check and make sure I didn't miss any other questions. I just happened to notice that one. Sure, you're welcome. Okay, I think that's it. Anyway, sometimes I see those questions out of the corner of my eye and sometimes I don't. So bear with me if I take a while to spot your question. Okay, so we've got our widget defined in our web component, but we leave the component type property empty. So it's actually even simpler to configure the form. Now the URL does have to be set in the form field value for our web component. So there's three ways that we can do that. You can do it dynamically. Essentially you're just forcing the URL is what we're doing here. Display WC URL to WC field. There's an example of defining the URL in a variable or assigning the URL to a variable we've defined and then displaying that to the form field in the screen record. So that would work. You can also do it this way, defining the field value as a string and then assigning it here, assigning the URL to the variable and using the display by name. And then finally you can also use a variable in an input dialog and you use the unbuffered option so that if the user, let's say in our Google Maps example here, if the user enters a new location, let's say, that unbuffered attribute automatically accepts the change. It's not buffered so that the form field automatically updates, right, to represent or to display that new location. So our screen record and our program variable are updated one right after the other. That's what that unbuffered does for us. So you should see the change immediately, right? It's invoked immediately that way. So that input by name allows the user to interact with the web component. And we'll see more of an example here in just a minute. So to detect a change, we said that there's a special control block that you can use with URL-based web components, and it's the onChange control block. So in this input by name, that's where you would have this onChange block would be in a dialog statement. Grab my highlighter here. In this example, I've got an input by name, and if the user enters anything into this form field, that automatically triggers this onChange. So that, like if he types in a new URL, for example, or anything that changes the URL, like in our example, that triggers this onChange block, and you can do whatever you like in your onChange block. In my case, I couldn't think of anything really to do, so I just displayed a message. URL has changed, just to show you that onChange block does work. Anytime a user interacts with the web component, makes a change to any of the properties or that form field value in the web component, it triggers that onChange. So we've seen this before. We talked about this the special web component front call module in the gICAPI topic. So this is the same front call method that we talked about before. You can use those with URL-based web components as well as gICAPI web components. So this is not new. This is actually a review. I left it in here though just to remind you that we have these special front calls that you can use to interact with web components. For debugging web components, you can use the graphical debugger that I've shown you a few times here in class to debug the parts that interact with your 4GL program. So those are especially useful for debugging gICAPI web component, for URL-based web components. You can use them with the gICAPI web components as well, but anytime that it's working within the interface script, the debugger just kind of leaves you hanging at that point. So in that case, when you're working with these gICAPI web components, there's third-party debuggers that you can use, like Mozilla Firebug. There's a JavaScript debugger. These gICAPI, those interface scripts, typically involve JavaScript. So you need a JavaScript debugger if you think there's a problem with the actual interface scripts. So it has features, though, that are a lot like the Genero Studio graphical debugger. So if you get familiar with our debugger that we've been using to show you things here in class, then you can also use the Firebug debugger as well. Most of them have similar features. Okay, so that pops us off into another topic. So I found that web component from the example. Let me just find the right project for it. So here it is, just to give you a look at that. Oops, lost it again here. Let me drag this one off and get rid of it. One second, bear with me here. It looks like I might have closed it out, maybe on our break. Here we go. One second. Okay. All right, here it is, finally. So this is the Google Maps example that we had the screenshots of in the last topic. So just to give you an idea of what that looks like and how it works. Let me just go ahead and run it here since you've seen some of the code already. We'll just take a peek. I accidentally, there we go. That message I've got in there is every time a URL change is detected, it's popping up that message, right, that the URL has changed. So with me tinkering with it like that, it's automatically triggering that onChange control block that we saw earlier. So this is what it looks like, just a simple URL-based web component to interact with Google Maps here. They've set a default URL. So let me show you that code right here. Notice it's bringing up Paris automatically without me going in there and tinkering with it or typing in any kind of a location. So right up here you can see they're using a constant CG maps and specifying maps.google.com. So they're actually just hard coding part of that URL that we're using. And then right here they've got a special record defined. My map is a string, location is a string, and then there's a value member as well defined as a string. So we're just opening the form, displaying the form, and then right here we're just using a let statement, let rec.location equal Paris. So they're hard coding that first initial location so that there'll be something there for the user to see when the web component comes up. And then they're using another let statement here to define my map equal to the CG maps, which is our http maps.google.com up here at the top, with this Paris location. So they're just concatenating the two together with the double pipe symbols there. So that's our initial location. So that's why it comes up showing Google Maps. And then here's our input by name. So we're allowing the user there to actually enter a different location into this web component. And then we're using this on change here to notice whenever a user makes a change. But all I'm doing in this case is sending out a message. URL has changed. But since those attributes are unbuffered, as soon as the user enters a new location, that URL automatically is changed and the information there in the web component is updated immediately. So that's all you have to do. Well, actually, there's one more thing that made me realize that I hadn't showed you something. Let me go back to the form for just a second because I forgot to show you kind of an important part here. And later on you would wonder about that, I imagine. So notice in this particular form field, this is just to allow the user to make a change. So notice that we have a button edit widget. If you remember, we used button edit widgets before in our project so that we could trigger an action with a button edit widget. That's one of our two widgets that I can think of off the top of my head that let you trigger an action. So here's our button edit widget. And down here in the miscellaneous, if you remember, for button edit widgets, the action is defined here in the miscellaneous section. So here's the set loc is the name of the action. And I completely forgot to show you that a few minutes ago, and it's important for this particular web component. So let's go back now to the code, now that you know when the user types in a new location and clicks that button edit, right, selects the button edit, he's triggering an action on action set loc, and then that's causing our URL, or the pieces and parts that make up our URL, to change, and then that is automatically being defined for our form field. So it's automatically being updated because of this unbuffered attribute. So I beg your pardon, it wasn't quite as simple as I made it look. You still need, in this case, the button edit that fires an action to change the parts of that URL so it can be updated with the new location. All right, a bit of an oversight there, but at least I caught it before we got too far. So that is a URL-based web component. Now in your lab this afternoon, you'll be working with a totally different URL-based web component that I think is a lot of fun to work with. It's a browser web component it's similar to this Google Maps example because you'll be using a URL since it's a URL-based web component. But this time you'll actually be displaying different things like, let's see, video, right? I think I have you display some video in the lab as well as maybe an HTML document. So that will be fun, and it's an easy way to get started with URL-based web components too. This Google Maps example was more complicated than the one you'll be working with in the lab. So let's look at our last topic of the day is on data synchronization. We've just got a few pages here on data synchronization using the Pool Doctors app as an example. We've talked a few times about partially connected apps and the idea that the Pool Doctors app is a partially connected app. And the reason we say that it is because we do have the DVM and everything right there on the local client, on the device itself. The runtime and the client are both there on the device. So in that respect, it's a standalone app. But in order to update his database, right, the technician's database on a regular basis, he needs to be able to connect to a back-end service on demand, in his case, to be able to add any new jobs that have been entered at the headquarters and also to upload any jobs that he's completed from his device. So that's an example of a partially connected app. It's able to run standalone without a connection to a back-end server, but it does need that connection occasionally in order to do some type of synchronization routine. Like in our case, we're synchronizing our database. So the Pool Doctors app uses RESTful methods to do the synchronization, and it's using web services with JSON over HTTP for that. So the synchronization process that Pool Doctors uses to synchronize the database, the first test to make sure that the device has a network connection, right? There might be lots of times out on the job where there's not a network connection available, so it's good to check for that before you start a synchronization routine and provide a graceful exit if there's no network connection. So the first thing it does is test whether the device has a network connection. And then defining variables for HTTP requests and responses. We'll see that we have special methods there from that COM package that we talked about briefly a few days ago. We're using some special classes and methods from that. And we'll create and perform HTTP requests for the service URL, perform response status and error checking, and then assuming that everything goes well and we get data from our back-end server, we're going to convert this serialized data string into something that can be inserted into our database here locally. So that has to be converted. And we've got some special JSON classes that we can use to convert that serialized data back to a format that can be read and inserted into a database with SQL. And then finally the last step there, after parsing through this JSON string and converting it to a BDL format or a 4GL format that can be used with a BDL program and inserted, we're going to actually insert those records into a table. So just some snippets of code from the Pool Doctors application. Here we're testing for a network connection. Remember, the first thing you probably ought to do if you need to synchronize with a back-end server is make sure you have a network connection and then offer a graceful out if not, right? Some sort of graceful exit without bombing the program. So that's what this does. It has a special function here that it calls called test connected. It's first checking here to see, remember this from a few days ago, this base.application.isMobile is a special method that's checking to make sure that the app is running in what we could call standalone mode, right? The runtime is on the device itself. It's not in development mode. The runner is on the device. So it's checking for that, making sure it's not connected to a server or communicating with a server, and then assuming that it is, I think I read that backwards. Let me read it again. If it's not, is modeled, then return true. Okay, so if it's in development mode, it's going to return right back to the calling function there. But if it is in standalone mode, it's going on here to this call UI.interface.frontCall. And here's another one of these front call methods. I don't think we talked about this specific one, but we did talk about the standard module that's provided. And here's a special method in that standard module to get the IP address, right? So it's the FE-info function, and we're trying to get an IP address from it. And then we're storing that in a variable, LIP address. And here we're checking the length of the IP address, and if it's greater than 0, then we're assuming that we have a network connection. So that's using a special method, a front call method out there to try to get the IP address for a device, and if that IP address exists, if it's greater than 0, then we're assuming that we're connected. Everything looks good. And so now the synchronization routine will continue. Otherwise, it's going to return false, and then we should have a graceful exit from the synchronization routine. So this is assuming that everything went well with that first step of checking for a connection. So now here we're looking at some actual methods to synchronize some data, and it looks like specifically we're looking at customer data to be refreshed. So here's a function that's using some of these special class methods from the COM package. And remember, all of these C extension libraries that we've talked about in the last couple of weeks, before I can use these special classes and methods, I have to import that COM package into my BDL module. So we don't see that here, but it's up at the top. So we have the import statement up at the top, and then we can use these special class methods. So just to run through these, so here we're defining some variables of the special COM package HTTP request class, and another one here for HTTP response objects. So we're defining variables for those. Then we're specifying the URL of our service that we're wanting to communicate with on the back end to be able to get some refresh data for our customer table, it looks like. And then we're building a request from that here with this HTTP request.create method. So that creates the actual HTTP request from that URL. And then we're also defining here a variable to catch the response. And then we're checking the status here. If response or resp.getStatusCode equal 200, then everything is good in this case. Otherwise, return false and get the status description. Try to find out what happened. So assuming everything went well, right, and we were able to get the data for that refresh process, then we're showing some JSON methods here. That data, when it comes in, is going to be serialized data. It's going to be in a format, like a big long string type format that we can't use directly to insert into our customer table or whatever table we happen to be working with. Instead, we're going to use these special class methods to parse out these JSON strings as serialized data and convert it then to VDL formats so that we can then turn around and insert it back into the table. And that's what this is doing. We've got a couple of special methods here I'll point out. Here they're defining a record to hold the data once it's parsed out. Here's another record here that's been defined like the table that we're going to insert the data into. So we're going to parse it out, parse out these strings, and then populate this record so that we can turn around and insert the values from the record into the table. So here we've got this, and I'll show you this in a minute in the actual application, this get text response. We're basically filling a variable with this serialized data at that point. And then we're using this JSON object.parse method to go in and actually parse through that serialized data And then here's the special method toFGL. We're taking that and using that to populate this record, this JRESP record. So that's the way that particular method works. You actually pass it the name of the record that you want it to populate when it goes through and does the conversion. So it's converting the data and populating this record with this one statement here. And then here's our begin work. And then here if we have any matching records already in the database, any matching rows, it's going to delete those so it can refresh them in case there's been any changes to the customer. And then it's going through here, and for each one of these parsed records that we have out, parsed and converted records, we're going to go in here and assign the value from the JSON record into our BDL type record once it's been converted. It's going through and converting it, and then we're loading it into our record that has our converted data in it. And then here's our insert statement to actually load those values, insert those values into the table. So we do have, as you just saw, we have some special utility classes that are created just for JSON, doing things like this to convert data to or from a JSON string and manipulate JSON objects like we saw in that previous example. So notice they're all part of the util package, all these different classes. So there's a util.json class that has a basic interface to convert program variable values to or from JSON data. We've got this util.json object class that gives us methods to handle JSON objects, and then JSON array class, of course, to allow us to manipulate JSON string syntax or JSON arrays. So 3 different special classes just for JSON. So that was a brief overview of the way that Pool Doctors manages synchronization from a back-end server. There's also some samples out there if you are interested in looking more into it. The Stores2 demo database is the Stores demo that we've had with Gennaro for years and years, but we've used that and made some changes to it for things like synchronization, and it actually has a sync routine in it that you can look at to give you some more examples of how to manage synchronization inside your app. So there's at least 2 places where you can get some idea. So that's the end of the actual PowerPoint presentation. What we might do is just take a look at some of these synchronization or the synchronization routine in Pool Doctors. I think I closed it out here. Let me pop this over for just a minute and I'll open it and I'll give you just a quick view of it. Grab it here. So I think, again, I think the debugger might be kind of a fun way for you to look at it, and it'll certainly make it easier for me to move around in there. So I'm just going to pull up the debugger here. I've got it fired up. Pull this over so you can see. There we go. Now over here in the menu, if you've experimented any with well, you probably won't be able to experiment much with it until after your lab today, but over here is a sync option here in this example. So when I click this sync option, it's going to go through and try to do the synchronization routine that the tech would do when he's out on the job. So for us to look at that, I'm going to go ahead and hit this interrupt up here so that it won't bypass us here. So here I am waiting at this input by name that we just talked about a few minutes ago with our Splash web component. But here I'm not interested in the Splash web component anymore. I'm more interested in this routine. So I'm going to click sync here. So notice it's waiting on me because I've got the debugger going. So I'm just going to move that out of the way. And I'm going to go here and click next. And now you can see that since I clicked that sync menu option, it put me into an on action block here called on action refresh. So that's the action I actually triggered when I clicked sync. So here it's calling a function called jobSync, a module jobSync.execute, so an execute function. So we can open that up just by stepping into it, if you remember the step in. And there's that first function that we talked about in our PowerPoint slides. It's first checking for a good connection, a network connection, before it actually starts the synchronization routine. So in our case, we are running on the server. We're connected to the server, so we're not going to get too far in this because it's not running right now as a kind of in standalone mode, right? The device itself doesn't have the DVM running on it. So if not test connected, then turn false. Not going to worry about that. So here we're scrolling down here, and the first one that comes up at the top here is refresh product. All of the rest of these are done in a very similar fashion, so I think if we just look at refresh product, that will probably be enough to understand the synchronization routine. So let's go ahead and step into that. Notice right now we're in this job sync module. That's his synchronization module that he's using. So here we are now in this private function refresh product. So here we saw all of this in our PowerPoint slide, so this should look familiar. Going through and defining or hard coding a URL for the service request, creating that HTTP request from the URL that was hard coded. And now we're actually performing the request. Takes a second or two. You pop up this data here so that you can see some of these values that are coming through. I'll move this over so you can see more. And then let RESP equal .get response. And if it's successful, then I'm going to get a status code 200. Open those up so we can see them when they change. Okay. So here we're saying, okay, that looked good, so let's go ahead and get text response, another method here. And you can see here that this get text response is actually, the response we have here is to actually get some values. I'm going to double click that so you can see what this data looks like. So you can see it's serialized data. It would be very difficult to try to insert that directly into the table, right? So that's why we need all of these special JSON methods to go through and parse through this big bunch of JSON string stuff that we see here, parse it out and create records from it that in turn can be turned around and converted to BDL format so that we can insert those into the database. But that's what the data looks like here when we're retrieving it. So here now we're getting ready to go through and parse through all of that and convert it to something that can be inserted into the database. So that's this 2FGL, and then as that's going on here, we're ready now to insert this into the database as we convert it. So here you can see they're just assigning values to the members of the record here. And it's in a loop. I think there's something like, let's just see here. Yeah, there's like 128 records here. So instead of going through all of those, I'm just going to give myself a breakpoint right there at the end of this for loop, because you probably don't want to see me pop through 128 of these iterations. So I'm just going to hit continue, and we'll go ahead and do that on its own time, and then it pops back out here so that I have control of it again. So here we're going in, just getting a count at that point and committing work. All right, so that was That was basically the synchronization routine for one table. And like I said, all the other tables are very similar, so we won't go through all of those, but just to give you an idea what that looks like. So that's one example of a synchronization routine, and again, that Stores 2 demo that's provided has a different synchronization routine. So if you're looking for ideas, you might try both of those. All right, well, that takes care of presentation, and I guess one more thing to be done here is to go through the lab, and then I'll turn you loose for the day. So this is Lab 9, Rapid App Development with Genera Mobile Lab 9 on Advanced Topics. The first exercise is you're going to implement the splash screen that we were looking at earlier today so that your app looks like my app does today. So again, it's a gICAPI web component, remember, so you're going to need to have available these source files, the interface file, programmable.html. I'm going to have you move that around some to make sure you put it in the standard directory structures. So that's what's going on here, and then importing the splash.4gl module. Remember, it's an external module, so you'll have to import it. And in exercise 2 is the URL-based web component example that I was telling you about. This one is using a URL-based web component as a browser. So I'm going to have you look at some examples of using that browser web component, and then I'm going to have you implement it and use it for a few things yourself. And then finally, exercise 3 is just to explore the Pool Doctor synchronization process, which we've done, I think, pretty thoroughly here in class already. So if you did want to skip that last exercise, you're free to do so. There's nothing in there that's going to be an issue for the next set of labs. So no dependencies, you're just simply walking through the code for that one. So do at least exercise 1 and exercise 2 so that you can see your new splash screen and try out a URL-based web component, and I'll make exercise 3 optional today.